Okay, page 147, number 16. All right, so we got a weird dice here. We've got numbers 1, 3, 5, 5, 6, 6 on this dice. First thing you want to do, find the probability of obtaining at least 7 odd numbers in 8 throws of the dice. All right, well, the probability of getting an odd number out of this dice is 4 out of 6, or 2/3. And then I should ask myself, is this a binomial distribution? And yes, it is, because we're talking about odd or not odd. And obviously we're throwing a dice, the probability should be the same. So I've got 8 trials. And so now I can use my combinations. And so I need to have at least 7 odds out of 8 trials. Well, if that's going to work, I need first try 7. So if I get 8 out of 7, that's 2/3 to the 7th and 1/3 to the 1st. And then that's going to give me 1,024 over 6,561, or 0.15607. And then, of course, I could get 8 out of 8. That's 2/3 to the 8th, 1/3 to the 0. And that's going to give me 256 over 6561, or 0.0390. If you add those together, you're going to get 0.19507, or 0.195 should be the probability of getting odds at least 7 times out of 8. Now, for the second part, they wanted probability distribution. I need a little bit of room. And they've worked out the table for us. That was really nice. And so all I got to do now is figure out what my possibilities are. Well, obviously I've got a 2, and there's 4, and a 6, and a 7, and an 8, and a 9. All I got to do is write down all the possibilities of my probability distribution table and then figure out how many times they happened. There's 6 sides, so there's 36 possibilities altogether. So my x's, well, there could be a 2. There also could be a 4, a 6, a 7, an 8, a 9, a 10, an 11, and a 12. And now all I got to do is probability for those. Well, there's 36 out of each one. So let's see. If you take a look here, I've got 1, 2. So the probability of that, let's think about it. 1 out of 36. All right, that's not too bad. How many 4s are there? Well, it looks like there's just 2 of them. So that's 2 out of 36. Are you getting the hang of this? So how many 6s are there? Looks like there's 5 6s. All right, so 7s, 8s. All you got to do is count. How many of them out of 36 are there? And then we keep on going until we get all the way across the top. Ooh, I'm getting tired. Okay, so let's see, those 12. Looks like there's 4 of them. All right, so now that's a distribution table. For part 3, they want us to figure out the expected value. Well, that's not going to be too difficult. All I've got to do is multiply these. That's 236 plus 836 plus 3036 plus 2836 plus 3236 plus 3636 plus 4036 plus 8836 plus 4836. And again, you'll notice they all denominator 36. So really all I got to do is add up the tops, and I get 312 out of 36, or 8.67 is the expected value. All right, now in part 4, they want to know the probability of it being bigger than the expected value. Well, all I got to do is add up the probabilities for 9, 10, 11, and 12. 436, 436, 836, and another 436. If you add those up, you'll get 2036, or 5/9, which is going to be 0.556. That's the probability of it being greater than the expected value. All right. Thanks for watching. I hope that helped.